Today is a pivotal day in your life as you receive the degree that each of you has earned from our Granger College of Engineering.
What's up, guys? Happy 2025. Happy New Year. I've been thinking about this. I have all these grad school videos about my robotics journey, and it's been almost 2 years after graduation, and there's some really cool stuff I've been wanting to share. But first, my haircut is very long. Let's go get a haircut for 2025. Okay, first off, thank you guys so much for commenting and supporting me from previous video. I received some questions and I try to answer them as much as possible. So hopefully that was helpful to you guys. And today's video should be especially helpful for high schoolers who wants to participate in robotics into college or even grad school. I personally transitioned from biomedical engineering to robotics in just under 1 year. And it's a challenging path for sure, but hopefully by giving out this video and content that you guys can take a shorter path and have a clearer goal and understanding of what to take and what to look out for. So if this video ends up being helpful, please consider subscribing and give it a thumbs up. So before I got admitted to the robotics program in my grad school, I thought I should be reviewing some of the topics to kind of help me kickstart in my robotics career. And I did some research over the summer before that. I found out it is more beneficial to review linear algebra. At that time, I was using Python already, but it's really for data analysis. So I kind of brushed up on Python. So the University of Michigan has this Robotics 101 course, and they have a full YouTube video for free for you to kind of take it and see it as, use it as a review. The course kind of goes over linear algebra, the basics of linear algebra has been combined with robotics, so that was very helpful. The professor Grizzle, who was the course instructor, he mentioned like calculus was very useful, but linear algebra is really the fundamental of robotics to begin with. There's just lots of linear algebra that you need to use or utilize for that. And so when I was taking this Robotics 101, it was very good review because they do Python, Julia, and combined with linear algebra, but also introduce you about robotics applications. The course took me about a month, give or take. I spent about 2 to 4 hours a day to review over the summer. And after I studied, I know I got accepted to it, so I decided just to go have fun couple weeks before the grind begins in grad school. Alright, so let's talk about my grad school curriculums. So this curriculum was kind of scheduled for 1.5 years and maybe a little bit more. But because I was one of the pilot students, the pioneer students, and there's actually 2 of us got admitted to that program. We tried to do it in 1 year, which is crazy now that I think of it. But basically within 1 year, if you sacrifice all your weekends, you should be able to do it. I definitely don't recommend people who are just starting grad school or coming to US to study grad school or not familiar with university systems and the stress load. I definitely recommend you do 1.5 year. This also gives you some time and leeway to do internship over the summer or maybe co-ops. I think that it is more beneficial. However, if time and money is your consideration and you're kind of stressed about it or restricted by it, I would definitely challenge you to try to take it over just under 1 year. And that was the case for me because I paid my grad school out of pocket. And adding 1 more semester just could be a little bit more costly. I think I was paying at about $20,000 per semester, I believe, or was that 1 full year? I can't remember. I'll probably throw up some screens about that. So the more semesters you stay in the university, the more expensive it gets, but with the caveat that you get more networking and you talk to professors and you have more exposure and hands-on experience in the lab or do something else. with it. But anyway, so the first semester begins and you kind of pick your courses. Most of them are intros. So we have Intro to Robotics. So this Intro to Robotics class actually follows the Northwestern University's curriculum. And they have a textbook made by Professor Lynch. It's called the Modern Robotics, Mechanic, Planning, and Control. And they also have a free Coursera that you can basically just take the entire course without going to university. So I think that was really nice. Also, we heavily use this textbook as reference, so you can definitely just go through the textbook. It's also free online. But a couple topics that you would learn. You learn about kinematics, so velocity kinematics. You learn about the basics of Jacobians, inverse kinematics, and by the way, I'm throwing all these terms. I don't expect you to understand if you're just starting. But I hope these could be good keywords for you to do some research on your own and why they're important. But yeah, if you want me to explain further, just leave the comments below. I'll try to make maybe another video. Anyway, so you have these open-closed chains. You learn about the trajectory generation. And we use this robot called the Universal Robot. The UR3 is the model that we were using. And then in this class, during the lab, you get some exposure to learning ROS, the robotic operating system, which is very helpful at the time. And you learn to calculate inverse kinematics, which is a way to control joints of the robot arm to the desired position. And then there's forward kinematics, which is vice versa of that. You learn how to calculate all the joint positions, doing some trigonometry. So guys, when you're in high school, pay attention to your trigs. It'll come in handy in robotics. Like, I kid you not. But if not, it's not too challenging. You just need a couple of reviews. But the more degrees of freedom that your robot arm has, the more challenging when you calculate the inverse kinematics. We also learned how to do some simple tasks using the robot arm. You do something like Tower of Hanoi, where you have to stack cubes on top of each other in a specific sequence. They teach you about teach pendant, which is kind of a cool way that you have like a tablet and you can control robot arms through that. And towards the end of the semester, you do some simple computer vision to find the centroid of cubes, and you try to align them for a pick and place. And yeah, so that was basically it. It's still a lot of things in there that you have to learn, but I would say it's a solid introduction. If you just follow the book or the YouTube, it's definitely really helpful. And then you have this second class that I took is called the Robot Dynamics, which is basically a more condensed, more in-depth of the Intro to Robotics. Yeah, so in this Robot Dynamic class taught my professor, who's now in the Boston Dynamics workforce, he really made this class enjoyable, challenging, but also eye-opening as well. In this class, you learn about homogeneous transformation, you learn about forward and inverse kinematics, Lagrangians, manipulators, EOM, Newton-Euler, actuator transmissions, dynamics, joint PID controller, which is very common, simulations are pretty cool, and control robot. You got some path planning, trajectories. And it gets to very interesting during the lab. You have these things called impedance control, contact, and impact. It has to do with force controls. So imagine you are moving your robot arm and you can actually stiffen one axis, let's say the X angle, but you can move Y along the Y, which is really cool. And then you can utilize that to apply a specific amount of force onto an egg. And that will come in later in our final project. But we also learn about hybrid force velocity control. That was the egg pressing I was talking about. A little bit about adaptive control, and you learn some collision avoidance using the potential field. It's kind of like a gravity thing. And I think our final was a trajectory optimization. So you can optimize in many things in robotics. You can optimize what is the shortest distance, what is the shortest time. You can even optimize what is the shortest consumption of energy, or in this case, electricity for that. It's really cool. This class is basically a very fast pace of the Intro to Robotics. The forward kinematics and inverse kinematics took us about 3, 4, 5 weeks in the intro robotics. When I was taking the robot dynamics, it only took us 1 week. And so we basically breezed through the homogeneous transformation, forward, inverse kinematics. So if you're up for it, I personally think you could skip the intro to robotics and just jump into the robot dynamics. And we have a textbook. The textbook that we use is called the Robot Modeling and Control. And it's by Spong and Hutchinson, and I can't even pronounce the last person. But this class, the lab, was the most beneficial to me. And that's something you have to think about when you go to grad school versus self-taught robotics, is that you have the exposure to actual robots hands-on that you can program. And that's something that's really hard when you're doing a self-taught curriculum. It's just you don't have access to these expensive robotics arms. And that's something to think about, whether it's worth it or not. But anyway, for this lab, first off, it was very interesting during that semester. I was the only grad school taking this. Well, not the only one, but I got paired up with some senior level undergrad. So they were pretty much done for their college career, and they're just trying to exit and graduate. The lab was supposed to have 4 people per group. And towards not even half of the semester, 3 of my members already dropped the class. So the entire time throughout the semester when I took this robotics dynamic class, I was basically soloing a 4-man project throughout the entire semester. So it was a lot of work, and each report I have to write, on average, I would say about 20 to 30 pages with images included, but it was a lot of work. And I really wish that there were at least 1 or 2 partners with me. But blessings in disguise, this is the most in-depth, most knowledgeable I got just by soloing, doing everything on my own, figuring out the robotics arm, asking professors, and I have the full time of controlling this robot arm because no one was on my team. And so that was kind of interesting. But I really learned a lot in manipulators, and I love them. They're very cool to watch and to control. Okay, so on to my third class, which is the Mechatronics. It's very interesting as well. This class is mostly hands-on. You were given a Texas Instrument chip, a development board called the TMS 320F28379D development board. And you learn about the basics of embedded side towards the bare metal, so GPIOs, core processing, bits, memory address, scope, communication protocols, the USB UART, SPI or SPI, the ADC, DAC, SOC, clock signals, MOSI, and MISO. I know it sounds a lot of gibberish, and MISO, no, it's not the soup, it's the master input and slave output. A little bit joke is that when you're doing mechatronics and embedded stuff, there's a lot of terms relating to masters and slaves, so it's kind of interesting. And then we learn about some sensors, so IMU, servo controls, motors, LiDAR, and a little bit of computer vision again. We also did some A-star path planning for that. And yeah, for the final project, you control this robot through the maze using A-star for planning and avoiding the obstacles. And you have to find these balls that are orange and purple using computer visions, and you pick them up and then you have to drop them off at a specific zone. So it was very useful, very interesting. You also, I think the personal project, you have to use IMU and servo to come up with something. For me, I did a kind of a pan tilt control with IMU for a ball to get up the maze. I guess maze is a common topic in this class. Oh, by the way, this course is also online, and you can basically see all the lectures as well if you're interested. And I'll post a link probably below in the descriptions. All right, on to the last class of my first semester. This is the Principles of Safe Autonomy. Honestly, I think it's really interesting, but given that it's an intro class, there's a lot of mix of topics between all these intros. So by the time I've been taking all 4 classes that has overlaps, it gets a little bit redundant and boring, and I wish there's a little bit more new topics for it, because after all, I'm paying my money for it, right? But anyway, the most beneficial of this class is you learn about what it takes to have a more safe environment for the robot and for the human, especially when it comes to the robot taxi nowadays, or even for robot in the warehouse. Is how do you know that your robot is in a safe environment but also in a safe state when you're doing the algorithms? I don't remember too much about it, but you have some stability called the Lyapunov stability. You can calculate what is it becomes chaotic or things like that. We did some overlap on computer vision as well, a little bit on ROS. We have this GEM vehicle that will later be used in the second semester. As far as simulations, you do it in ROS, the robotic operating system. We have gazebos and Carla for simulations. You learn how to do a particle filter, which is a localization technique for robots. And you do some basic lane detections, steering angles for that, for your autonomous vehicle car. And for the final project, we do something called the Grace Challenge. You basically have the car that goes through the laps. You're trying to avoid obstacles as well, but also find the optimum path for racing. It's pretty cool. And for this class, there are two reference textbooks that we use. One is the very well-known Planning Algorithms by Stephen Vallel. And then the other one is kind of what people call the Robotics Bible, which is the Probabilistic Robotics by Sebastian Thrun, the father of autonomous vehicle. Those are the folks that made the Udacity course with Waymo as well. Definitely give it a shot. I think the probabilistic robotics would be more beneficial, and I've seen several people recommend this book as well. I personally didn't really read through the entire book, mostly use it for reference and just combined with YouTube. Now that I think of it, I'm thinking about going back to read this textbook again just to solidify my basics and fundamentals, and that could really help. So first semester, that's basically it. Let's talk about summer, what I did after that first semester. I was very eager in finding an internship. That is something that's very important for joining the industrial force and the workforce, is having an internship and basically tell the recruiters like, hey, I did my interns and I'm capable of the big boy jobs, you know. I did two things. So one, I found an internship at that time. It was through my professor. This internship was more kind of a startup environment, and I was doing it more like an IoT device development for that. Basically, we do some indoor localizations, and there's some challenges with that. So just imagine in indoor, your GPS would not work really well. So what do you do with it? And what are some robotics applications that you can utilize to compensate the GPS uncertainty? And the second part, what I was trying to do was checking out a robotics lab, and they do a lot of teleoperation robots. They were onto a challenge called the challenge is called the ANA Avatar X Prize, the teleoperated robot. They have a full-on robot that you can control with VR. And so on that robot, you have two robotics arms, you have a base rover that kind of navigates throughout. So I was fortunate to have two PhD students that kind of guide me throughout. Unfortunately, I just did not have the time to even contribute to the labs. I was mostly just watching them and auditing, and I kind of dropped out afterwards. And this is what I was saying, if you want to crank out the 1-year plan for grad school, it's like you really have to sacrifice some stuff. Things like this that could be beneficial. Joining a lab could be really helpful, especially if they let you do hands-on robotics work. And so I personally think if I would have done a 1.5-year program, I would join them and try to do as much hands-on project as possible. But either way, I got an internship, so I was fine with it, to be honest. And this internship kind of helps serve as my capstone program, so that was really helpful. That's how I was able to kind of shorten my stay in grad school. But yeah, on to the second semester. So the second semester was even more interesting, I think, and it gets a little deeper in grad school. for second semester, I took some classes. The first one being the autonomous vehicle systems. So this one, we were using the Jam vehicle again, and I really like this because you were sitting in an autonomous vehicle and you were programming it. The lectures basically covers basic CNN. You have some image classification detections. You learn about ROS again as well, and PacMod. You learn about point set registrations for point clouds. How do you associate point clouds to point clouds or maps to maps? And then you tune the PID for this car as well, which is really cool. My professor was kind of okay during this class. I had to supplement with a lot of outside reference or resources. One of them being the Dr. Serial's lecture, linked on YouTube. He is probably one of the best educator on YouTube for autonomous vehicles. If you want to do some self-taught, highly recommend watching all his videos about SLAM, simultaneous localizations and mapping. And speaking of SLAM, if you want to learn more on SLAM, there's a GitHub list of all the SLAMs you can learn from it. I'll put a lot more resources in the descriptions as well. But back to the projects in this class, we learn about how to control blinking lights. And this car, you utilize something called the drive-by-wire, which basically have a controller in the car and it's electric. And then there's a very beefy computer or I guess just imagine your high-end gaming computer that's slapped into this golf cart. And it can perform autonomous waypoint missions and path planning. For the exercise that we did in the cars, we did something called like the pedestrian avoidance. We did something related to mapping as well. And you have these path planning waypoint missions in real time. So we were sitting in a car and you created a path. We did like a figure 8 thing for the car to move around. And I was able to control a life-size golf cart with a controller. I can accelerate. Here, let me grab a controller. So I was able to control a full-size vehicle with a controller. I can accelerate and brake with the controller, which is very interesting. It's a surreal experience. It's like you're sitting in a toy car controlled by it, but then you realize you can actually drive this car on the real road as well. So that was very interesting. And obviously for the final project is you have to do an autonomous waypoint missions. Hands-free, no hands. So you just let the car run, you programmed it, you let the car run throughout the course with specific patterns. And that was very cool. I really enjoyed that a lot. Had a very good teammates around, so shout out to them. And they're in a lot of good spots right now. Alright, on to another class. I was taking computer vision. This one is very helpful if you want to go into perceptions or machine learning with computer visions. A lot of robots need to see the world, but how do you interpret that world? And that's through computer vision with that. The course is also available online if you just want to check it out. Something to highlight, I want to leave most of the topics in computer vision out just for you to research on it. But things to highlight are the optical flow, the multi-view geometry, and feature detectors. These are very common, and I just love my professor. She's super great, super helpful, and she explains in a pretty good job. Like, I enjoy it a lot. All her lectures are publicly available. And we did a detector, key point detector. That is very useful. And also something to take note of computer vision. There's kind of two sides now. There you have the kind of the old school traditional geometric computer vision geometry, and you also have the modern machine learning computer visions. Yeah, so you should still definitely take the geometric computer vision because it teaches you the fundamentals of cameras and multi-camera systems, how to calibrate them, what is the pinhole model and why is that useful or unuseful sometimes. And a lot of robotics algorithm builds on top of your understanding in computer vision as well. Once you have this understanding, you could kind of segue into the machine learning, more modern techniques of computer vision. Overall, very good class. Even the MPs, the machine problems or the homeworks are very useful. Alright, on to the last class of my second semester, which is the mobile robotics. This one, another super helpful class that I wish I took it early. Honestly, this could be highly recommend to be the first first class in college, even for undergrad, for grad schools. It's a super great exposure. And so my professor was very passionate about this topic, so it makes the class very interesting and helpful. We went through linear algebra again and some probability as just first 2 weeks to kind of refresh. And then you get into state space systems. So state space is very helpful and when you're doing things like combining sensors, what we call the sensor fusions. And you learn about the robot dynamics, but more on the vehicles instead of the robot arm. The vehicles have different kind of the model. Something's called the bicycle model. Is a way to estimate, how does your car dynamic work, and you can simulate that through a bicycle model. You learn about different sensors, so IMU, GPS, camera, the LiDAR, radar, all these stuff that you see on like a Waymo vehicle, that we learn about it and how to utilize them. What are the pros and cons? You learn about debt reckoning. So how do you imagine you close your eyes? How do you get an estimate of where you are? And so the same thing applies to robots. If the robot does not have a camera or a LiDAR, but has an internal sensor like the IMU or the GNSS, how do you estimate where you are through that? And that's something called the debt reckoning. Or even the motor, right? You can use the revolution of the motor to kind of estimate how far you've gone with that. And then now you have the exteroceptive sensors. So now your robot opens your eyes and can hear and can see, and with cameras, with LiDAR. So how do you estimate? How do you see the world through that? And you get into some more like computer science stuff, the vector graph. This is particularly important for SLAM, or the EKF SLAM, the extended common filter SLAM, which is arguably the more old school way of doing SLAM nowadays. But it's still very helpful just to understand how SLAM runs overall in the pipeline. We covered a little bit on visual SLAM, how to use computer vision combined with localization and mapping. So visual SLAM is very useful in autonomous vehicle, in drones. How do you locate the robot on its own without using GNSS, or maybe combined with GNSS, right? We talk about what happens when you're indoor and your GPS doesn't work. There are some ways to combine that, and one of the ways is using the visual aspect. There's something called the visual inertial odometry, which you can use your camera and kind of track where you are. It's very cool. If you look at the Apple Vision Pro, that's basically it. And then you learn about the controls again, but for autonomous vehicles. This class was very useful in its homework and lab as well. This is probably the most hands-on of ROS that I've ever learned. You learn about RVIS, the transformation tree, the TF. You learn how to utilize ROSBAG, which is a very good way of recording all your sensor data without repeating your robots running around in the field. And that was pretty helpful. You record the data, and then you can run your algorithms on top of that over and over again. That's repetitive. You learn about how to program callbacks in your robotics loop. You implement some of the LiDAR SLAM. We did something called the segmentation or fitting line. We implemented bicycle model and then PID control for steering, for velocity control. We also implemented an actual EKF filter, extended common filter with GPS and IMU. So the application for that is, like I said, right, when you have GPS and when that fails, what do you do with it? You can combine with your IMU to do something called the debt reckoning. So basically you have two sensors that you're computing, and you're constantly trying to judge, okay, right now my GPS is pretty good, my algorithm should use GPS. And then you coupled a little bit of determining factor with the IMU. So you have two sensors, the GPS and IMU, that estimate your location. And then your algorithm is saying, okay, which one should I trust more right now? The common filter turns out to be a super, super useful algorithm or filter that has been used throughout, even in defense, in planes. And for the final project, at least for the grad school, we learn about RTAB map, which is a way of doing the RGB SLAM for that. Oh, and there's some couple cool stuff I did towards the end of semester. That is the soft robotics. It's something you don't see a lot, but soft robotics has a pretty cool application or place in my heart that you can use, especially in the medical field or maybe in agriculture. But that will be another story of its own. I just put some montage and videos on it. It was basically we were building some soft robotics for fish, and the tail would just wiggle, and that was kind of fun. And you can use soft robot arms to grab things without breaking the items. And that's basically it with all the classes I've taken. Now, because it's 1 year, I have to jam pack all the classes, and it still honestly feels like intro. I know people who are doing the 2-year curriculums, like the Masters of Science, they go more in depth in certain topics as well. But it's a very good intro, but also adds a little bit of thickness of knowledge or the depth of knowledge for me. And so the challenge right now is to really hone in one subject to be the expert of that. That was kind of my hope. And I'm kind of leaning towards computer vision just because I find it fascinating. I've been always interested in cameras and taking photos. And there's just so much you can do with computer visions. But I heard the job market is a little bit saturated with computer vision as well. So are the techs. We'll see. I also tried to audit the deep learning for computer vision sensors and instruments, but I was kind of busy with my internship. I decided to extend that throughout the semester for fall. They were doing some competitions and I really wanted to help out. But I probably should pay attention a little bit to the class. Anyway, I did pretty well with my grades overall. I had a 3.9 out of the 4. So my grades was pretty good. And I would advise anyone who's doing grad school and undergrad to really get more hands-on experience. Just start building stuff, start implementing stuff, start coding, get your hand touched on any robot parts that you can. And this way, when you are talking to your recruiters, to someone else, you really have a compelling story and a confident to advance your career in that. Okay, so I actually am talking a lot and getting tired. With regards to job market, I would say jobs are definitely out there, especially in the West Coast, East Coast of United States. A lot of robotics companies are mostly still in the startup state. Unless you do automations, manufacturers, those are pretty solidified and still a huge need for that. Yeah, so looking back with grad school, there were a lot of challenges, but it was very rewarding. And if I could do it over again, I would spend more times really to just do hands-on projects or labs instead of taking extra classes. Robotics is truly a learn by doing field, right? You just want to get your hands dirty, get your feet dirty, walk around, do some testings, and that's how you learn. And really, you don't have to go to grad school or college to start your robotics journey, right? The most important is just having something and start building. You have an idea, let's start building. Especially with ChatGPT, all the Gen AI stuff being really good now, I would say it's the easiest to learn robotics on your own and to figure it out. Your internet is your teacher. ChatGPT can help you. And the rest is really how passionate are you and how motivated are you to build stuff, even if it fails, right? Doing robots, you have to be okay to fail and fail fast. Yeah, really embrace the mistakes. It will make you a better engineer in general as well. It's really exactly how you learn in the real world. You learn by doing, you make mistakes, and you iterate and you improve. That's the life of engineers, and even more so for roboticists. So there you go, guys. That was my grad school journey. I hope that was helpful to you guys. If it was helpful or if you have any questions, don't forget to subscribe, leave a thumbs up, and comment down below. And lastly, I want to encourage you again, robotics is just such an amazing field, and it's also complicated. There's a lot to learn. The best thing you should do is just, after this video, just go and do. And that's the best advice I could give to anyone who wants to embark in this robotics journey. I personally still feel like I am new into robotics, so this is something I am learning, constantly learning as well. And again, I'm excited to share my robotics journey with you. And so let's just go build some robots today. And that's the end of the video. Thank you so much for watching again, and I'll see you on the next one.